Hey guys, so the first video, of course, only had time to really focus on the polynomial division part of our review. On this video, I want to focus on how do we find the volume of a box. So if you're having problems with that, go ahead and continue watching. So, like I told you guys in class today, you are going to get a box tomorrow. You're not going to get a box, actually. You're going to get a piece of paper. And you are going to have to maximize the volume of that paper. You're going to have to measure it on your own. And then you're going to have to, let's actually move this over here. I don't want it to be too big in my way. You're going to have to determine the function for the volume of the box. It's going to be an open box that you need to make. You're going to have to graph the function. You are going to have to tell me what the domain is and what the range is, as well as what the length, the width, and the height is. And I'm going to do one right now. Let's say that I took out my handy dandy ruler and I measured that this side was 24 and this side here were 30 inches. Well, to make our box, as we've done in class, we need to cut off the corners using squares. There's no such thing as a square. But anyways, we cut out our squares, and then of course this is where the dashed lines are where we would fold our boxes up. The equation for volume, of course, is length times width times height. So again, these little corners, imagine that they're gone. They're not here anymore. We cut them out and recycled them. So the resulting length of, or excuse me, the resulting width of my box would be, well, I started off with 24 inches, but then I cut off two unknown lengths of squares. And what do we use for unknowns? We use x. So I subtracted 1x from the top and subtracted 1x from the bottom when I started off with 24. So this resulting length is going to be 24 minus 2x across the top, and then that means I got the same 30 across the bottom. I started off with 30, but then I cut off 1x, and then I cut off another 1x. So this length across the bottom is going to be 30 minus 2x. And of course, if I fold my box up, if I fold all the sides up, the height of my box is simply going to be this length. When they come up, fold up, and touch each other, it's going to be a length of x. So if I put all three of those together, my length is 30 minus 2x. My width is 24 minus 2x. And the height of my box is x. So your next step is to plug this into your calculator. I will give you the window. The window for this problem is, if I were going straight down, it would be 0, 14 with a scale of 2, and 0 to 500 with a scale of 100. So if you want to pause to go ahead and see if you can do this on your own and then come back and look at the answers, that would be lovely. But I'm just going to quick sketch this. 6, 8, 10, 12, 14. Starting with 2. This is going to be, excuse me, I need to just learn how to spell. This is going to be the height of my box in inches, always. And from here, 2, 3, 4, 5, up to 500. This is always going to be my volume in inches cubed. And usually I wouldn't write on this side, but I ran out of room. So, sketch your graph, and you should sketch it more clearly than me. And actually, I'm off a little bit, I think. Let's see, let's try this one more time. Something like that. It was supposed to be ending right there. So what you need to do is find the domain. Remember, when we're talking about domain, we're talking about football. And what I mean by that is, think about the goalpost. It's all good as long as it's in between the goal, right? So in this case, my domain is going to be 0 all the way over to, I want to know what are the x values that are included. What's the span? It goes from 0 to what? I do believe it goes from 0 to 12. If you cannot tell where it goes, you need to go in your calculator and press second calc and 0. From there, you need to press 1 and enter. And whatever your the right-hand side of our window that we selected was, in this case, our window we set was 14. So I would press 1, enter, 14, enter, and enter one more time. And it would have given you this point. It would tell you that your domain, or well, it would have told you that this point was at 12. And that's how you get your domain. You always get this from the 0. All right, next, since we're talking about range, I'm talking about hamburgers, right? Where's my top bun? And where's my bottom bun? So, I actually want to start with my bottom bun. It's pretty easy. It's starting at y equals 0. Now I want to know where my top bun is. Well, my top bun is always going to lie at the top of my graph. So there's something in a calculator that we can use to find the top of the graph, and that's the maximum. So you go to second, calc, max. And this time we're going to pick from our left-hand bound, which was 0. That's what we selected. So I would press, run out of room. I would press 0, enter, and then the right-hand side of our boundary was 14. So I would press 14 and enter, and then enter one more time. If you do that, you should get an ordered pair. You're going to need that x value and the y value. The y value, or the ordered pair that you should have gotten, was 4.417, 1417 point, should be a decimal point, 0.873. This ordered pair is very, very important. This ordered pair is telling me where my maximum volume is. My y value is over here, is my maximum volume. So it is at 1,417.873. And sorry, that's all jammed up looking. Let me write it down here. 1,400 and 17.873. And with that, I do believe that my scale is way off. I think the scale maybe should be 1,500. I think the scale might need to be 1,500. You can try to go back and see if you're having difficulties with your graph. All right, so that's your ordered pair that you should have gotten. The maximum volume is 1,417.873 cubic inches, because length times width times height. The 3 different terms that we're multiplying. And so then we use our equations that we came up with up here and use them to find the actual dimensions of the box, the actual length, the actual width, and the actual height. So we're going to use 30 minus 2 times, and wherever we're going to get this x from, we're going to get this x from our ordered pair, because that is the x value that we need in order to get the maximum size box. The maximum size volume from this box. So I'm going to plug in order to get this max of 1,417.873 cubic inches, I'm going to have to use 4.417, as my x. So you plug it in right here. You use your handy dandy calculator, and you should have gotten 21.166 inches. You need to do the same thing with the width, using 24 minus 2 times 4.417, and you should have gotten 15.166 inches. And last but not least, the height of my box is simply going to be 4.417 inches. It's equal to x. So on your test, I'm going to expect you to be able to do all of this simply from one sheet of paper.